Hi all. The last session we have seen how to find the complementary function of a linear ordinary differential equation with constant coefficients of second order. Okay, so today we are going to see how to obtain the particular integral of a linear differential equation. And we have seen this is the standard form of the linear ODE. D square plus a1d plus a naught of y is equal to x of x, where this one is a function of x. And in short, if we denote d square plus a1d plus a naught as a function of d, we can write this as f of d of y is equal to x of x. All right, and we have seen in the last session that the solution of such a differential equation contains two different parts. The first part being the complementary function, and the other one is the particular integral. And we have seen in detail that how to find the complementary function. So today we are going to discuss the method of obtaining particular integrals. So and to find this particular integral, see, we just focus only on its working procedure. Okay, so I'll write the formulas and everything directly, and when we get a problem we apply it and we solve the problem. And we are not going to discuss the theoretical part of these kind of problems right now. All right, so to find the particular integral, see, we denote the particular integral as yp, and that is yp is equal to the function on the right side x. We can write that as x by f of d. X by f of d. See, you take this y f of d to the right side, x by f of d, and this one actually 1 by f of d is an operator that operates on x, so we'll get a function of x. The question is, how can we find out that function? And that is the question. And here this working procedure says that, see, if we know that x is a function of x, right? So if certain kind of functions, we can find this particular integral using this procedure or this method. Okay, so these are the possible functions of which we can find the particular integral. Are it can be e to the power ax, all right, this is one of the functions, or sine ax or cos ax, all right. Then a polynomial, I'll just write that as some p of x, it's a polynomial, and then some e to the power ax times x. That means a combination of like e to the power ax sine bx, or e to the power ax cos bx, or some e to the power ax times another polynomial, some x square plus 1, something like that. So these are the four different kinds of functions of which we can find the particular integral. And for other functions again we can find a particular integral, but we are not going to discuss that method here. Okay, so now we are going to discuss one by one each of these cases. Okay, so first let's focus on the particular integral of e to the power ax. So case 1, if the right hand side function x is equal to e to the power ax, okay, then the particular integral corresponds to this one is equal to, as we have written before, we write this as e to the power ax by f of d, right? And then what we do is just replace this d by a. A is the coefficient of x, just replace this d by a. So we'll get e to the power ax by f of d. f of a, sorry, f of a, and this is going to be the particular integral corresponds to e to the power ax. But the problem is that when you substitute a for d, this one should not be 0. Okay, so we have a condition, f of a should not be equal to 0. All right, so if that becomes 0, okay, then we can write e to the power ax by, that means if f of a is equal to 0, then you write an x here, and then the particular integral of e to the power ax by f dash of a. This is what the formula. All right, if f of a equal to 0, you take the derivative of this f, then substitute a. Okay, and again provided f dash of a not equal to 0, and again if f dash of a becomes 0, then you have to write one more x here, so x squared times e to the power ax over f double dash of a, and here the condition is f dash of a, f double dash of a not equal to 0, and f dash of a equal to 0, and you can continue this procedure. Okay, and now let's focus. Okay, we'll do problem based on this. So this is a question, solve d squared plus 5d plus 6 of 5 is equal to e to the power x plus e to the power minus 2x. Okay, so we have to solve this problem. So the first thing, however, we have to find the complementary function, right? And then we have to find the particular integral. Actually, on the right side, we have two functions. One is e to the power x, the other one is e to the power minus 2x. So we have to find particular integral of each of these functions separately, and finally we have to add all these functions together. Okay, so the complementary function, to find the complementary function, first we write the auxiliary equation as m squared plus 5m plus 6 is equal to 0. So find two numbers whose product is 6 and sum is 5. So when you solve this one, you will get m is equal to minus 2 and minus 3, right? So we can find the complementary function yc as some constant c1 e to the power minus 2x plus some constant c2 e to the power minus 3x. This is the complementary function, the first part of the problem. Now the second part, we are supposed to calculate the particular integral yp of e to the power x. Okay, yp of e to the power x. We call that as some yp1. Okay, yp1, and to get that, this is a formula, e to the power x by, and write the function of d in the denominator. So we'll get d squared plus 5d plus 6. Okay, d squared plus 5d plus 6. Now these are the formulas. So what we are supposed to do is just replace d by a. A is the coefficient of x. So here the coefficient of x is just 1. So substitute 1 for d and simplify it. So e to the power x by 1 square plus 5 times 1 plus 6, and you will get e to the power x by 12. Alright, and this is the particular integral corresponds to e to the power x. The same way we can find the particular integral corresponds to e to the power minus 2x. I'll write it here. particular integral of e to the power minus 2x. We call that as yp2, and which is obtained by e to the power minus 2x by then d squared plus 5d plus 6, right? So here again the same procedure, just replace d by minus 2. So when you substitute minus 2 here, this is what you will get: minus 2 square plus 5 times minus 2 plus 6, right? So we'll get this one as 0. And this is the case then. That means when you substitute minus 2 here, the denominator becomes 0. Okay, then you have to put an x, then e to the power minus 2x, then find the derivative of this one with respect to d. So derivative of d square is 2d plus derivative of 5 times d is just 5. Okay, and again you continue the procedure as you substitute, or you just replace d by minus 2, substitute minus 2 here. So x times e to the power minus 2x by minus 4 plus 5, and that is going to be 1. So x times e to the power minus 2x, and we have obtained the particular integral of e to the power minus 2x also. Okay, now the problem is completed, since the solution of the differential equation y is equal to yc plus yp, and here especially we have two functions, so yp1 plus yp2, and the answer is c1 e to the power minus 2x plus c2 e to the power minus 3x plus yp1 is e to the power x by 12, and finally we have x e to the power minus 2x, and this is what the solution of this differential equation. All right, and this is the first case. If x is equal to an exponential function, this is how we solve this is how we find the particular integral and final solution. Okay, now we move on to the second case. Well, case 2, if x is equal to sine ax or cos ax, both have the same procedure, and this is how we do it. The particular integral yp is equal to sine ax over, we write f of d, right? Now this is the only method. Here just replace d square by minus of a square. Okay, and see, f of d is a function of d, so there can be the terms of d square, so only those d square are to be replaced by minus a square. Okay, the other terms remain the same. Okay, so we'll do some problems based on this one. This is the first question, solve, or I'll write we are going to find only the particular integral of problems here. Okay, we are not going to solve completely the problem. So find the particular integral of d square plus d minus x of y is equal to sine 2x. Okay, so actually to solve this one we have to find the complementary function and particular integral, but here the question is to find only the particular integral, so we focus only on that. So here particular integral is equal to sine 2x divided by the function of d. Okay, now the method is this: replace d square by minus a square. Okay, so here a is equal to 2, a is equal to 2, minus a square is equal to minus 2 square, that is minus 4. That means we are going to replace this d square by minus 4. So you'll get sine 2x over minus 4 plus d minus 6, and you will get sine 2x by d minus 10. But still this is not complete, right? See, the denominator contains again a d. So however, we have to eliminate that one also. So what we are going to do is just multiply both numerator and denominator with the conjugate of this one. In the sense, we multiply both numerator and denominator of this with d plus 10. So d plus 10 of sine 2x over d plus 10 times d minus 10. Okay, and when you multiply this one, you will get d of sine 2x plus 10 sine 2x divided by, this is a plus b times a minus b, so we'll get d square minus 10 square, which is equal to, d means derivative, so find the derivative of sine 2x. We'll get 2 cos 2x plus 10 sine 2x over, again we have to apply the same procedure. See, replace d square by minus a square. That means this d square can be replaced by minus 4 again. So you'll get this d square is replaced by minus 4. So minus 4 minus 100. And the answer is 1 by minus 1 by 104 times 2 cos 2x plus 10 sine 2x. This is the particular integral of this problem. All right. Hope you understand that. Next, we'll do one more problem. Second question. Find the particular integral of d square plus 1 of y is equal to cos x. Okay, or let's solve this problem. Okay, so first we find the complementary function. So the auxiliary equation is m square plus 1 is equal to 0. When you solve this one, you will get m is equal to plus or minus I. It's a complex root you will get. Therefore, the complementary function is e to the power, here the real part is 0, right? Real part of the function is 0. So c1 cos, imaginary part is 1, c1 cos x plus c2 sin x. Since there is no real part, that e to the power term won't be there. Okay, and now we are going to find the particular integral yp is equal to cos x by d square plus 1 right? Cos x by d square plus 1. Again the same procedure. We here a is the coefficient of x, that is 1, so minus a square will be minus 1 square, so we'll get minus 1. So when you replace this d square by minus 1, you'll get minus 1 plus 1 will be 0, right? So this will be 0. So in that case we follow the same procedure as we have seen in e to the power ax. That means you put an x here, then cos x by, find the derivative of this, so you'll get 2d. Okay, since the denominator becomes 0, right? So minus 1 plus 1 is equal to 0. Okay, so x times cos x by 2d, and here we have a 1 by d. So again we have two options here. Either we can multiply both numerator and denominator with d. So this will be d cos x by 2d square, and you can replace that d square by minus 1. Okay, or note that d is the differential operator, right? D by dx, and 1 by d is its inverse operator. That means inverse operator in the sense, if d represents the derivative, 1 by d represents integral. So 1 by d is the integral operator. All right, so here we have a 1 by d. That means we are supposed to integrate this. 2 is a constant, so x by 2 times integral cos x dx, as 1 by d is the integral operator. So integral of cos x is sin x, so x by 2 times sin x. All right, and one more thing, this particular integral does not contain any arbitrary constants, but complementary function will contain arbitrary constants. Okay, therefore even if you find the integral, you are not supposed to add a constant here, because particular integral doesn't have any arbitrary constants. So the solution, y is equal to yc plus yp, and yc is c1 cos x plus c2 sin x plus x by 2 sin x. This is the solution of this differential equation. Okay, so that's all about case 2. Now let's see case 3. Okay, now case 3, if x is a polynomial, then how can we find the particular integral? And here we are supposed to memorize certain series expansions, like 1 minus x the whole to the power minus 1 is equal to 1 plus x squared plus x cube plus etc. Similarly, 1 plus x all to the power minus 1 is equal to this one will have alternate plus and minus. So 1 minus x plus x squared minus x cube plus etc. Okay, so just memorize these two results. Okay, now here to find the particular integral, again we write this as p of x over f of d. Now what we do is we write this f of d as one of these two forms. Either we write this as some 1 plus some function of d to the power minus 1, or 1 minus some function of d to the power minus 1. That is, we have to rearrange f of d in this form, some 1 plus or minus some function of d to the power minus 1 p of x. Okay, sometimes there can be some constants outside. Okay, so rewrite 1 over f of d as some k times 1 plus or minus phi of d to the power minus 1, and use any of these two results, expand this one and multiply and simplify it. Okay, so when we do a problem, I think this will be more clear. So I'll write a problem here. Solve y is equal to d squared plus d of y, which is equal to x squared plus 2x plus 4. This is a problem, and this one is a polynomial, right? Polynomial means it may contain more terms like this. Okay, and this one is a second degree polynomial. So solve this. Okay, now find the complementary function. So write the auxiliary equation as m squared plus m is equal to 0. When you solve it, you will get 0 and minus 1. So the complementary function yc is equal to c1 e to the power 0x plus e2 e to the power minus x. This is the complementary function. Okay, now the particular integral yp is equal to x squared plus 2x plus 4 over d squared plus d. Okay, so so here what we are going to do is we write this as some 1 plus or 1 minus, okay, some function of d. Okay, so however we need to get 1 here, right? So factor out, we can factor out d square, we can factor out either d square or d, right? But when you factor out d square, here you will get 1 by d. That will be more complicated. So when you factor out d here, so if you factor out this d, or if you take out this d, you'll get x squared plus 2x plus 4 over d times, take out this d, and you can write this as 1 plus d. Okay, when you take 1d from here, it remains d. When you take out d from here, you will get 1. So d times 1 plus d, and this is of that form, right? So 1 plus phi of d form, 1 plus d, and write this part to the numerator. So 1 by d is here, so let it be there, and take 1 plus d to the numerator. So this will be 1 plus d to the power minus 1 of x squared plus 2x plus 4, right? Now we have the formula, right? 1 plus x all raised to minus 1. Apply the formula. 1 by d is there. When you apply the formula there, 1 minus x plus x squared minus x cubed plus etc. times x squared plus 2x plus 4. Okay, now the thing is that this one is a second degree equation. So we need to have, actually this one has infinite number of terms, right? So we don't need all those terms, but we need the terms up to degree 2, because this one is a second degree polynomial. So we can take only these 3 terms, and simply we can avoid all the other terms, as this one is the third derivative of a second degree polynomial will be 0. Okay, so this is going to be 1 by d of 1 minus d plus d square of x squared plus 2x plus 4. So 1 by d of, now you multiply it, 1 times the whole thing, x squared plus 2x plus 4, and this is d, derivative of this polynomial is 2x plus 2. D square means second derivative of this polynomial, and that is going to be, this is the first derivative, So once again you find the derivative. You'll get only 2. Okay, 1 times this one, derivative of the whole thing, and second derivative of the whole thing. Okay, now you simplify it. X square plus 2x minus 2x will be cancelled. 4, this is minus 2 plus 2, so plus 4 you will get. All the other terms will be cancelled, and 1 by d means integral, right? We have seen that. So it's integral x squared plus 4 dx. So the answer is x cubed by 3 plus 4x. X cubed by 3 plus 4x. So we got the complementary function and the particular integral. So the final solution is the sum of these two. So y is equal to yc plus yp. I'm not going to write it. Yc is this and yp is this. Okay, and this is how we find the particular integral if the right hand side is a polynomial. Okay, so the method is simple. You, however, take out some terms and make it as some 1 plus phi of d to the power minus 1 or 1 minus phi of d to the power minus 1. Expand it and simplify it. Okay. All right, and there is one more case, and case 4. Okay, and in case 4, if x is of this form, e to the power ax times another function of x, and this can be a polynomial function or trigonometry functions like sine ax or cos ax. Okay, and this is the method to find the particular integral here. E to the power ax times x over, we can write that f of d here. Now actually in this case it's enough to find the particular integral of x, but that means we can take out e to the power ax, right? E to the power ax comes out and find the particular integral of x. But the only difference is that when you find the particular integral of x, it's not just d, but d has to be replaced by d plus a. That's it. Okay, that means if the function is of this form, you find the particular integral of x with f of d plus a, not just f of d, but f of d plus a. Okay, so we'll do a problem. Find the particular integral of t square minus 2d plus 4 of y is equal to e to the power x cos x. This is a problem. All right, so here x is equal to cos x, right? Okay, so to find the particular integral, this is what you are supposed to do. E to the power x times cos x over, write down the function of d in the denominator, d square minus 2d plus 4, right? Now here it's enough to find the particular integral of cos x. You can take out e to the power x, but when you take out e to the power x, you have to replace d by d plus a. Here a is the coefficient of x and that is 1. So d will be changed as d plus 1 the whole square minus 2 times d plus 1 plus 4, right? And you simplify this one and find the particular integral of cos x. Okay, so e to the power x times cos x over, expand this one, d plus 1 the whole square, d square plus 2d plus 1 minus 2d minus 2 plus 4. Okay, 2d will be cancelled So cos x over d square plus 3, right? D square plus 3. This is what the function is, the simplified form. Now we are supposed to calculate the particular integral of cos x, right? So what we have to do is just replace d square by minus a square. Here minus a square is coefficient of x is 1, so we'll get minus 1. So e to the power x by cos x by d square is replaced by minus a square, that is minus 1 plus 3, that is e to the power x times cos x by 2. This is what the particular integral is. So actually this case is simple. We can take out e to the power ax, then d has to be replaced by d plus a. Okay, then find the particular integral of this part only, x by f of d plus a. You simplify that. That depends on x. If it's a function of sin x or cos x, we have to follow the steps of that. And if it's a polynomial, we have to do that method, right? And we will do one more problem. All right, solve t square plus 4 of y is equal to x sin x. X sin x. Actually here finding complementary function would be easier, no problem, but particular integral, see, this is not this function x sin x is not in any of the forms which we have seen, right? This is not e to the power x. This is not just sin x or cos x. This is not a polynomial. And it's not like e to the power ax times something, no, right? So this one is a different function, x sin x. So how this can be solved? The only thing is that we have to convert this function into any of the functions which we have seen. Then only we can apply those methods, right? So try to convert this sin x as an exponential function. Try to convert sin x as an exponential function. So we know that e to the power ix, we have studied this in complex. E to the power ix is actually cos x plus I sin x. Cos x plus I sin x. Or we can write sin x as, and this one is a complex number, right? Real part plus I times imaginary part. So sin x is nothing but the imaginary part, right? The imaginary part, IP in the sense imaginary part of e to the power ix, right? So in this case, to find the particular integral, we write this sin x as imaginary part of e to the power ix. Then we follow the procedure. So first let's find the particular integral yp. So yp is equal to x sin x over d square plus 4, and we write sin x as imaginary part of e to the power ix by x square plus 4. All right, now this imaginary part, we can take it out. Can write the imaginary part of the whole function. So x times e to the power ix by x, sorry, this is d square plus 4. D square plus 4, right? Now this is of the last form, right? E to the power ax times a function by f of d. So we can write e to the power ix out, e to the power ix times, then it's enough to find the particular integral of x, but d has to be replaced as d plus I, because I is the coefficient of x here. So d plus I the whole square plus 4, right? So imaginary part of e to the power ix times x by, simplify this one, get d square plus 2id minus 1, I square is minus 1 plus 4, right? So this is imaginary part of, again, e to the power ix, simplify this one, x by, I'll write this time first, 4 minus 1 is 3 plus 2id plus d square, okay? And here it's a polynomial function, so try to convert this as some 1 plus phi of d or 1 minus phi of t. So imaginary part of e to the power ix times x over, we take out 3 times 1 plus 2 by 3 id plus d square by 3. This is what you will get. Now this is some 1 plus phi of t. You take this one as a single function. Okay, so you'll get imaginary part of e to the power ix over 3 times, write down this in the numerator, 1 plus 2 by 3 id plus d square by 3, the whole raised to minus 1 of x. Okay, whole raised to minus 1 of x. Now you expand this one, and this one is a polynomial function of degree 1, right? So it's enough to write only the first time, because the higher order terms will be 0. It's enough to write only the first time. Okay, I'll write it here. It is equal to imaginary part of e to the power ix by 3 times, formula is just 1 plus x all raised to minus 1. So 1 minus 2 by 3 id plus d square by 3 of x. Okay, higher order terms are not required, as this one is a function of x. I mean, a polynomial of degree 1. So it's imaginary part of e to the power ix by 3 times, you multiply this, 1 times x is x minus, now its derivative of x is just 1, so you'll get 2 by 3 I, derivative of x is 1, second derivative of x will be 0, that's it you will get. Okay, now you simplify this one. Now this one is a complex number, right? In terms of x, it's a complex number. You find the imaginary part of that complex number, that's it. So this 3 comes out, imaginary part of e raised to ix is cos x plus I sin x times x minus 2 by 3i. Okay, now when you multiply this one, first you collect all the real parts, so x cos x, then when you multiply this one you will get I square is minus 1, so that is 2 by 3 sin x plus, then times of I, x sin x, and then these two times minus 2 by 3 cos x, right? Okay, and this is a complex number. Now the imaginary part of this one, and this is the imaginary part, so that is going to be the answer. So 1 by 3 is a constant times the imaginary part of this complex number is x sin x minus 2 by 3 cos x. Fine, so that is the particular integral. I am not going to solve for the complementary function, so you can, I think you can do that. This is only the particular integral, so you find the complementary function and the sum of these two will give you the answer. All right, so that's all about the method of finding particular integral of certain standard functions. Okay, and this is the first part of finding method. To find the particular integral we have other methods to and this is the direct method, you can say. Now we are going to see some other methods of finding the particular integral called variation of parameters, method of undeterminate coefficients. Those two are two simple methods. You will see that in the next class. All right, and I'll give you some problems also